I bought this cheap air compressor used, and the pre-owner said that the fuse was triggered and there was sparks coming out, but yeah, the air compressor looks pretty new and it was only 30 euros, so almost nothing. It has pretty good values there, and I have exactly the same thing already. And I tried it, and you see here what's the issue. There's big blue sparks flying out, and then here in the close-up you see there is a lot of sparks flying, and that was exactly the moment when the fuse was triggered. So there is a switch in there which is actuated by the revs of the engine, and this contact here, which is copper, is also sometimes welded in that one position by the lining that is produced by the current of the motor when the switch is opening. And so I tried to bend the switch a little bit into a better place and give it a little bit of more pretension to have not that happening, and also tried cleaning the contact surface, but still led to the same issue all the time, that the contact was either freezing in the one position or throwing heavy sparks, and the fuse is triggered. So that's not something you want to have when you are using that air compressor, because you cannot be supervising the contact all the time. So try to debug that, and yeah, I didn't really get along with manipulating the contact. So yeah, first of all, what's this contact there? So there is two capacitors on the air compressor, and here's a website I want to show you about this. And this is a single-phase induction motor, so it works on your household energy, and you have a capacitor which gives a phase switch to the one phase of 90 degrees, so this is enough to turn the motor. And there is this switch which switches between the run and the start capacitor, and these both capacitors have different capacitance, and one gives you a higher torque, but this would be too much current for the motor to run all the time, so this would heat up the engine too much. And so there is a switch when the motor is revving to a certain speed, and then switches to this smaller capacitor. In this case it's a 50 microfarad capacitor to run and a 200 microfarad capacitor to start the engine, and this 200 microfarad capacitor has a nominal capacitance of 200 plus 30%, and by measuring the capacitance of the capacitor it shows that in both directions it's well within this band of tolerance. But still there is some trouble, and I thought that maybe this is caused by some sort of issue with too much current. So I tried buying two smaller capacitors, one with 150 microfarad and one with 100. I started trying with a 150 microfarad capacitor, and after some starting cycles you see here that the sparks are already reduced, and then from a sudden point they completely disappear. So maybe there was some other sort of issue with the capacitor, because by measuring it with a hand device, maybe that's not exactly what you see when you have the 250 volts or 230 volts from your power socket. So another issue then was, after sorting that out, to mount this a little bit bigger capacitor to this air compressor. So I just popped this cap, put out the original capacitor, bent some angular metal part, and then yeah, just tied that down with some zip ties. And yeah, that's been it. So then the rest is just putting the cables back, getting these zip ties to length with some sort of scissors, and then yeah, actually after some wiggling around with the contact switch and thinking about what's happening there, it was just actually quite an easy fix. And the pre-owner said already, like, maybe it's something with the capacitor, but that was just like more or less an educated guess. And I wanted to really sort that out before I buy some parts. It took me quite some time to really get there. And yeah, maybe I think that's pretty helpful for you. Maybe you have that same issue and sparks coming out of your air compressor or some sort of engine driven device. And yeah, now I just really make sure that all the screws are tight down really hard, so that there is a really good contact everywhere. I think that all the screws have not really been checked by the manufacturer really properly, and now it's all tied down properly and secured in place again. Just yeah, fix some zip ties to the cables and then put on the case again, and yeah, now you see it. It's just an pretty ordinary air compressor with a 2.2 horsepower, which is I think 170 watts or something, and 50 liters of capacity for the air. And it says on the label that it should suck in like maybe 450 liters per minute, which I think is a little bit optimistic, but the tank is full in I think more or less a good minute or so. And if you check that, how much air that is, so this is 50 liters by 1 bar, and you have 8 bars at the end, so it's almost 8 times that. So it's around 400 liters at 1 bar, roughly. So by sucking in all that air to that pressure on the outside, you have around maybe 350 liters, which is really sucked in and charged to that pressure, to that operation pressure on the outside. So actually that's pretty good, and this air compressor is built, I think, by many or sold by many vendors and or many suppliers. And this is from Aldi. The brand here, Workzone, is just a shop brand used by Aldi. There's other so-called, I would say, it's not manufacturers, but other sellers, yeah, that use this same more or less air compressor, and they're sold under Einhell, Scheppach, many others, I think, but that's at least for the German market for these cheaper models. It's a directly driven air compressor. You see here, and it has 2 pistons, and it's an oiled device, so it's not running dry. And I think, from my experience, because as I already said in the beginning, I have that same air compressor already. It's doing pretty well, and I just wanted to have another one, which I want to use in parallel afterwards. So stay tuned on that, because I'm going to modify these air compressors to run together. I also want to upgrade this thing here with an air dryer before the air is coming into the tank. So what you see on the other side, this tube with this aluminium radiator there, is yeah, actually I don't really know why they did that, because it's just for looks maybe, because the air, when it's coming out of the compression cylinder, of course, is really hot, and then it's forced through that tubing with this radiator spring on the outside. I just call that spring because, yeah, it's actually you wind it around the tube, and it's not really like having contact everywhere, so it's far from ideal. And yeah, it just sends in the air into the tank with maybe a couple of less degrees than coming out directly from the air cylinder. And yeah, it cools down in the tank anyway, so all the moisture that's stored in there is still in there, and that's far from ideal because you have that moisture in the tank then, and that leads to corrosion. And I don't know if you've seen that, but there's a video on YouTube with this one air compressor which was exploding in the shop, and it's actually pretty hefty, so it's more or less like a bomb happening there. And I don't want to have that, and also I think it's just for longevity, and I just want to make sure that that's not happening for me. But with the smaller capacitor there's another problem coming in now, because the start torque is now reduced by a significant amount, and if there is still pressure in the feed tube, the motor will not be able to start then if the air compressor is not switched off by the red button here, which would release the pressure on the feed tube, but just by pulling the switch. And in the situation where I use the air compressor, it's also done just by depowering the complete air compressor, because they have a timed power supply. So what's necessary to get rid of that problem is to put in a normally open solenoid into the feed tube, which is only then closed when the motor is also under current or under voltage, so under power. And this means that the normally open solenoid is then closing and the feed line is then shut, and the compressor will lead its pressure into the air tank. And by opening the solenoid, so by depowering the air compressor, the feed tube will always be depressurized. So for the next cycle there is no problem for the motor to start, and the contact is now, I think, very much improved, because there is a lot less sparks and a lot less fatigue on this contact. This is just what came out of the air compressor, because the pre-owner said that he never did that, but actually maybe then he just run it a couple of times, and I'm pretty lucky to have most new air compressor. So that's been it with the air compressor. I will see you in the next video for the installation of the solenoid. Have a great time and thanks for watching.